I'm not sure.
That's okay.
117.86.
Somewhere missing something somewhere.
173.71.
What?
176.7.
I think it's 179. Anybody get 179.87?
Not even close. No, not close at all.
Okay, first of all, if you can't write the formula, then you need to come in for tutorials because we will continue to use formulas for the whole next at least half of next semester. So like when we're balancing equations, I'll give them to you in words and you have to write the formula and then balance them. Or when we're doing stoichiometry, I'll give them to you in words because you know how to write the formulas. So if you are stuck with that and you thought, oh, we did it, we quizzed, we're moving on, we're never moving on from that. So as someone was saying, this 2 does not mean that iron has a subscript of 2. This means it has a +2 charge. And nitrate is a -1. So what should my formula be? And nitrate is NO3.
Fe1 NO3
With the 2. And we don't write the 1, right?
Wouldn't that be there's 2 compounds of nitrate?
No. This right here?
6 oxygen.
Are you asking me this Roman numeral?
No, not the numeral. I'm talking about nitrate. Would they be like 2 compounds of it?
Yeah, if you wanted to get the mass of a whole nitrate and multiply it by 2, that would work.
So you multiply it by 2.
Well, I do them as each separate element. So like I do iron, nitrogen, and oxygen.
There would be like 2 irons and 6 oxygen.
There's only 1 iron.
No, that'd be, yeah, you only multiply what's inside the ring.
Uh-huh.
So it'd be
There's only 1 iron.
6.
I mean, no, I'm talking about nitrogen, sorry.
2 nitrogen and 6 oxygen. Uh-huh.
Yeah, okay.
Sorry, now I got it.
See, yeah, that's where I messed up because I did only 1 compound as a nitrate.
Uh-huh.
And that's when you get 117.
Oh, okay.
And 86.
Yeah, that makes sense.
But I just didn't add another compound of nitrate.
So once you figure that out, then you multiply it by their atomic mass off the periodic table. We've done all this before, rounded to 2 places behind the decimal. So for iron, it's what, I think 55.85? And nitrogen, 14.01. Does that sound correct?
Yes.
And oxygen is 16. Yep, you multiply through 2 and what's 6 times 16? Oh, I can't do 32.
32.
No.
64.96. And then you add them all together. And what did I say it was? 179.87, I hope. Whoops, I lost it. Grams.
I feel like we all went pretty dead right there.
Grams per mole. Did y'all remember that was a unit?
Yeah.
I remember it was a unit. I just don't remember what unit.
So what Josue was saying is he got like that. He did like a little side calculation, getting the molar mass of what a nitrate was, and then he multiplied it by 2. So that would also work. All right. So y'all have done that before, and we're going to be doing it with what we're learning today. But this writing the formulas is not going to leave. It's not going to leave. If you can't do that, then there's no need to be in chemistry.
Chemistry's required though.
Once again, if you can't do that, there's no need for you to successfully be in chemistry, and especially not chemistry honors. If you want the easy route, come to regular chemistry. All righty. If you will, you need your pink sheet out, and you need your Chromebook. And if you have a quiz, let's see if it's dropped.
Number 3.
Yes, ma'am. Number 3, if it's open. Quiz nomenclature number 3. Jacob and Alejandro, that's what y'all should be working on. Jacob, get out of bed, please, sir. You have 8 minutes. acid. So once again, you can't do that if you can't write the formula. So you know it's acid, it's going to start with the hydrogen. And if it's bromic now, then originally it would have been bromate. So that's this ion, which has a -1 charge. So that means I do not have to give hydrogen a subscript. So it just would be HBrO3. So once I've done that, then I just start working with each element like we did on the warm-up. 3 times 16, that's the one I always know. For oxygen, bromine, I had 1. 79.90. 3 times 16 is 48. And a good old hydrogen, I have 1.01. So there are my 3, and I total them up to get my molar mass of my whole compound. 128.91 grams per mole. So if I remember correctly, when we did this earlier, the main problem was people put the wrong unit on or they were rounding. A lot of students struggle with rounding. The only way that you know you're rounding wrong is to do the practice, which I know the majority of y'all don't do, to do the practice and then to check it. That's the only way you're going to realize that you're rounding wrong. Because if you would have rounded wrong on this and you would have ended up with some other answer besides that, that would have been incorrect. So make sure you know what you're doing. We will quiz over percent composition, which we're getting ready to learn on Monday. That'll be our last quiz, open notes, no requizzes. All right, so we know how to do molar mass. Now what we're going to try to do is find the percent by mass of each element in the compound. So just like if I took 100 ping pong balls and 100 golf balls, I may have 100 of each, but which one's going to contribute a lot more to the mass? The golf balls. One golf ball is a lot heavier than one ping pong ball. Same thing in this compound. I may have 20 hydrogens in some formula, but all it does is take, one oxygen or one bromine, and it comes and cancels that out, and then they don't contribute as much. So we're going to start looking at what percent each element contributes to the overall mass. And since it's percent is always part of a whole. So that's what we're going to be looking at. And it's really pretty easy. Just can be sometimes a little time consuming. All right. So your first step when you do it is you got to write the correct formula for the compound. So if you're still struggling with formulas, you need to come in for some tutorials. Find the molar mass of the compound. Make sure that you're rounding correctly. Then you're going to divide the total atomic mass of each element by the molar mass of the whole compound. Multiply by 100 because we want it in percent. Sig figs don't come into play whenever you're finding percent composition because we're not using a measurement. So we're going to say 2 places behind the decimal, just like we agreed to take our atomic mass off of the periodic table, and then percent sign has to be there. 2 places past the decimal is like our classroom rule. You may have another teacher and that may have been 1 place, or you may go to college and they may tell you 4 places behind the decimal. So that's kind of up to what the teacher decides. All right, so let's just look at a problem. What is percent comp of each element in lead 2 phosphate? So once again, you got to write your formula. This 2, remember I always say it's like a little cheat sheet. I don't have to even look on my ion. That 2 tells me it's a +2. Does not tell me what the subscript should be. Phosphate is a -3. So you're trying to get 6 on each side. So PB, what's that subscript going to be? It has to be 3. Remember, think of them as switching. Phosphate, what's it going to be? Now it's going to be 2. So there's my correct formula. So I have lead, 3 atoms. I have phosphorus, 2 atoms, and I have oxygen, 4 times 2, 8. So now, right now, we're just working through to find the molar mass because that's the first step. 8 times 16 is 128. Phosphorus, I would have to look that one up. 97. So 61.94. And lead is pretty heavy at 207.20. So you get 621.60. Add them all up. 811.54 grams per mole. So that's kind of my first set of calculations, although it doesn't answer it. So we haven't done anything new yet. Now I'm going to start finding the percent of each element in that compound. So for lead, I'm going to take its total amount, 621.60, and divide it by the total compound, because that's my part, and then my whole would be the whole compound. So 811.54 and multiplied by 100, and I get 76.60%. Then I go to my next element, my phosphorus. My total amount of phosphorus, which is 61.94. Once again, divided by the total amount of my compound. So your denominator is going to be the same as we work through this. What's changing is your numerator. Once again, same 811.54 times 100, 7.63. And then very last one, I have my oxygen. Total amount, 128. Once again, divided by that same 811.54 times 100. Top number divided by my bottom number, 77%. And those would be this one had 3 answers. You would have 3 answers. So you can kind of do a double check with yourself. What do you think those should add up to?
100.
About 100. And I think this one happens to add up exactly to 100. Well, yeah, because, sometimes a little bit on the rounding may get you to 99.99 or 99 or 100.01 or something like that, but real close to 100. So notice my answers are still 2 places behind the decimal, okay? And it seemed like I was going to say something else, but I don't remember what that was. So does anybody have any questions where those numbers came from? Sometimes the question may just ask you to find the percent composition of one element out of it. So you still would have to go and find the molar mass of the whole compound. But then when you got to this step, you would have less work on that particular one. Because you can see it's not that they're hard, it's just that they can be a little time consuming. What do y'all think? Not too bad? All right, so let's flip over to the other page and y'all can try one. So we'll go here, we'll go down to percent composition. And why don't y'all give that one a try. Find the percent composition of mass by mass of sodium carbonate. Sodium is group 1, so it's a +1. And carbonate's a -2. That's a carbonate ion right there. So what's my formula going to be? Right, Na2CO3. Then I'll have a +2 versus a -2. And it'll be neutral overall. So I'm going to give you all a few minutes to work on that one.